PreCalc, PreCalc, PreCalc. We are studying the last topic in trig. So I don't know how you feel about that, but we are. Complex numbers in trig form, and you'll be watching this sometime after Friday's class, which is 1-6. So, alright. The topic is writing complex numbers in trig form, and then we'll pretty much tell you what that is tonight and prepare you for writing complex numbers in trig form, and then we'll learn how to multiply, divide, and raise them to powers and square root, and then we'll sadly be finished. We're not going to do all that tonight, but we will in the next day or two complete those topics and be done with trig. So, you recall the word complex numbers. Any number you've ever used is a complex number, and it has the form a plus bi, where a is the real part and bi is the imaginary part. And you'll recall imaginary meant from your pre-PreCalc classes. The square root of -1 does not exist because in the real number system, because what number times itself gives you -1. That's what a square root would be. So there is no number times itself that will give you -1. So we call it an I. When this first was thought of, it was sort of heretical and rejected by most mathematicians, so it took a while to catch on, and really we need it. We need it for our electronics. None of our TV screens would focus. They'd be all blurry if we didn't use I in electronics. It comes up all the time. And I'm not prepared to tell you in what way, but I have been told. So the square root of -1 is I, and in a complex number you have the real part followed by the imaginary part. For example, 3 plus 2i. So it has the real part followed by the imaginary part. Or -2 minus I, or -2 minus 2 square roots of 3i. So these are all examples of complex numbers. Right. Complex numbers can be graphed, but we are going to leave the real plane. In the olden days, this used to be the x-axis and this used to be the y-axis. That's called the real plane, but we are now in the complex plane, sometimes called the Argand plane, complex plane, and this axis is the real axis, and this axis is the imaginary axis. So if I'm going to graph 3 plus 2i, I graph the real part on what was the x-axis, so I come over 3, and I'm going to go up 2 on the imaginary axis, so right there, and I'll write it in 3 plus 2i. Alright, let's see if we can find this one. -2, -2 square roots of 3i. So in our thoughts, -2 minus 2 square roots of 3 is going to be approximately 3.5. So this means I'm going over to the left, -2 on the real axis, and down almost 3.5. So I'm going to go down about 3.5. And it'll give us a pretty good idea of where that is on the complex plane. So that's -2 minus 2 square roots of 3i. Alright, now that you have that, I'm going to teach you how to take a complex number and write it in trig form. And I'll explain later why we are going to go through this who-struck. So putting this in trig form. Right now, these are called standard form. That's when you have the A plus BI form. It's called standard form. So I'm going to teach you another way to write the same number, which will open up so many doors for you. So, complex numbers in trig form, here we come. The basics are, so there's going to be a number outside of a set of parentheses. A second here. There's going to be a number outside of parentheses. I'll just represent it with an R. Then there's going to be the word cosine, always. Then there's going to be an angle. Then there's going to be a plus or a minus sign. Then there's going to be an I. Then there's going to be a sign of this angle. So this is the basic form of trig form. We call it trig form because it has trig functions in it. And notice it has a real part and an imaginary part. And also, I want to point out that this angle is always the same as this angle. Alright, so let's do one and see how we actually get it into this form. So let's say we'll pick this one from our complex plane. 2 minus 2 square roots of 3i is in standard form. So I have to get it into this form. There's a number outside here, and that number is the magnitude of the complex number. So you probably have a pretty good idea what magnitude means. And from seeing what we have previously, even though we weren't using complex numbers, we were using vectors, but if I am looking for the magnitude of this complex number, I'm going to draw a line like a vector from the origin to the number, and I need to come up with that distance. That is the magnitude, and that's what we need for R. That's the magnitude. And I am going to make a triangle out of it. So I know from this name that I went back 2 and down 2 square roots of 3. So I'm going to Pythag that to come up with the magnitude. So back down here, I'm going to, under the square root sign, Pythagorean R, or the magnitude, is going to be the minus 2 squared, that's this part right here, plus this part squared. Alright, let's work that out. Minus 2 times itself is 4. Negative 2 square roots of 3 times negative 2 square roots of 3 gives us positive 2 times 2, which is 4, and then we have square root of 3 times square root of 3. Square root of 3 times square root of 3 is 3. 3 times 4 gives us 12. So we have R equals the square root of 16, and it comes out in this case to 4. Whoops, I lost you. Alright, there we go. 4 plus 12, 16, and now square root of 16 is 4. So we have found R. So I'll put it in its proper place outside of the parentheses. Then it's always followed by the word cosine, then an angle, and I'll leave that blank because I'm going to come back and get that angle, plus I sine of the same angle. So all I do is come up with the angle and I'm done. So going back to this graph, I'm going to come up with the angle, just like I did when I was studying vectors. And the angle is going to go from here all the way over to here. We always start our angles at the positive part of the x-axis, and we go counterclockwise until we hit the magnitude, and that will be the angle we're looking for. And just like we did when we were in vectors, we are going to use inverse tan, and it's always going to be if you recall, in vectors lands, it was the j part over the I part. But unfortunately, this used to be the I part and this the j part. Now, in the complex plane, this is the real part and this is the I part. Sorry about that, but life is cruel like that. So, anyway, I'm going to take this part, the imaginary part, and divide it by the real part, and that will be an inverse tan function. So I'll go tan inverse, and I have minus 2 square roots of 3 over minus 2. So when that happens, the negative 2's cancel, and I'm left with tan inverse of square root of 3. I can see very clearly that this number is in the third quadrant. So where in the third quadrant can I find an angle that has the tangent of square root of 3? And that will be my answer. So let's look at the unit circle. Somewhere, I think it's this one right here, where we go back negative 1/2 and down square root of 3 over 2. When I do that, is this second coordinate divided by the first going to give me the desired square root of 3 right here? Second divided by the first. Let's try it. Negative square root of 3 over 2 divided by negative 1/2. Dividing by 1/2 is like multiplying by 2 over 1, and negative times negative is positive. So we did find the correct spot. What angle is that? That is, let's see, we go 1/6 pi, 2/6 pi, 3, 4, 5, 6/6 pi, 7/6 pi, 8/6 pi. So that reduces to 4 pi over 3. So 4 pi over 3 is the inverse tan, and it is the angle that is represented right here. And so it will go in 4 pi over 3 and 4 pi over 3. Okay, I kind of got crowded out. Let me write it for you more clearly. So the R part was 4, the word cosine, then 4 pi over 3 plus I sine 4 pi over 3. You say, why is this formulated like this? And I can show you now, because this is called trig form. I'm going to ask you to go from trig form to standard form. And that's pretty much what your assignment's going to be, is going from trig to standard and standard to trig. So let's pretend we don't know where this started from, and this was the problem, and it is in trig form. You can tell because it has trig functions. Let's go back to standard form. Recall that's a plus bi. So to do that, you just simply multiply, distribute the 4 among these two expressions. What is the cosine of 4 pi over 3? Well, looking at the unit circle, we know where it is. Down here, again, this was negative 1/2 minus the square root of 3 over 2. So what's the cosine of that? First coordinate is minus 1/2. And what is sine of 4 pi over 3? Second coordinate, minus square root of 3 over 2. So I'm ready to distribute. What is 4 times minus 1/2? minus 2. What is 4 times minus square root of 3 over 2? So I'm going to write plus, and I'll write it out for you, 4 times minus square root of 3 over 2, and there's still an I in that term. So this 2 will go into the 4 2 times, and it becomes minus 2 minus, because of this minus, 2 square roots of 3i. And if you recall, that is where we started from when we began the problem. We were asked to put that into trig form. Then we got back to trig form by taking the cosine and sine and distributing the number here to each part. Alright, I'm just going to show you one, and that it won't make a whole lot of, you won't see its value until we get a little further into working with complex numbers in trig form. Okay, that's it. So I will see you Monday. Until then, have a good weekend and keep these things in mind. See you on Monday. Bye.